here at Tisdale Park in Coronado in front of an existing bike path. Our team, Aztec Structural Consultants, performed a feasibility study on the Coronado Bridge pedestrian tube, originally proposed by architect Lou Domini of Domo Studios.
The Coronado Bridge was built in 1969 and was overseen by Caltrans. It remains to be one of San Diego's most notable structures and one of the most iconic bridges in California. It spans an impressive 2.1 miles long, in which connects the Coronado Island to downtown San Diego. The current problem with Coronado Bridge is that as it stands, there exists no pedestrians or bicyclist access crossing points. Our team, Aztec Structural Consultants, composed of me, Fahad Farjas. I will be mainly covering the existing LOS, users' projections, and the bike sharing program.
Antonio Paez. I am the group's project manager, and I will be covering our group's findings for the structural analysis, method of construction, and the cost estimate.
I, Suzette Budari, will be covering the CEQA's the environmental checklist and the irrigation negative declaration.
I, Daniel Sandoval, and I'll be covering the geotechnical aspects, including soil property, soil analysis, and the existing fault zones.
In the transportation study, among the positive impacts of this project, such as health, environmental, and economical benefits, a main issue was the failing level of service in most of Coronado's streets. Additionally, as far as users' projections, the main factors are work, recreational, and summer commuters. Counts of monthly ridership and purpose of trips were obtained from MTS for bus routes 901 and 904. Right now, Route 901 is from Iris Avenue Transit Center to downtown San Diego, and Route 904 is from Coronado City Hall to the ferry landing in Coronado City. As a conservative assumption, we stated that 5% to 20% of only work commuters that will potentially choose the proposed bridge as a new path for commuting to work. In regards to the recreational users, we assumed at least 10% to 30% of the existing pedestrians and cyclists. Counts located in Coronado Bayshore and San Diego Harbor Drive based on EcoCounter. Furthermore, summer predictions were based on the average daily traffic increase for the Coronado Bay Bridge SR-75 during summer. We assumed only 5% of the increase, most likely from tourists that will be interested in commuting through Coronado Bridge pedestrian tube. The total monthly average is 17,000 commuters, and during summer it will be around 47,000. Other factors that will affect the summer increase will be attached in the transportation study. Furthermore, bike sharing program was launched in 2014 and is administered by the city of San Diego. There are 180 different solar stations around the city with 1,800 bikes that are available 24/7 at affordable prices. This project will also help expand this program as well as promoting health and help with the traffic congestions.
Structurally, the bridge was analyzed as a typical section and was designed from the slab out. The slab was designed with a live load of 100 pounds per square foot as required by AIC code. All of our findings and design are in compliance with AASHTO, AIC, and Caltrans regulations. For our bridge, the yield strength of our steel and our reinforced spars were designed at 60 KSI. The concrete was designed at 4 KSI, and the supporting wire that we used had an ultimate yield strength of 58 KSI. Our bending stress was set at 0.66 of our FY. In this case, it was 38.1 KSI. We then checked the deflections, and if they went over 3 inches, we set it equal to a max of 3-inch deflection. Our construction method analyzed the bridge at a calculated length of 35 feet, 8.5 inches, as pertaining to the structural calculations for a maximum deflection of 3 inches. The method we chose to go along with is one dubbed a dancing platform, for which we have a traffic plan in the traffic study in our binder. We looked at an underbridge crane, specifically the A30 UBIU with a maximum capacity of 600 pounds. It would then be used to temporarily install a hoist crane with a max capacity of 2 tons that weighs 300 pounds, safely within the underbridge crane's ratings. All of the steel and would be prefabricated, and all of the concrete would be pre-cured and installed as slabs. To maximize time of installment, it is possible to work from both sides. The cost for our structure was calculated per typical section at a mentioned length of 38 feet 8.5 inches, for which we will need a total of 310 sections to cover the 2.1 mile span. The total construction cost was estimated to be around $46.8 million, which includes the cost of rentals, fabrication, and erection, for which a figure of $7,000 per ton was used. Our findings also show that there will be a maintenance cost, which is roughly estimated to be $320,000 per year. Funding for our project is available through federal, state, and local agencies. We also looked into private funding and nonprofits, which are options and have been carried out in the past. The figure we came up with does not include inflation costs, but is something that needs to be considered.
Our submittal consists of the California Environmental Quality Act, initial study environmental checklist, which can be found in the list of exhibits to determine what study is needed according to the parameters of our project is proposed. After completing the checklist, the proposed tube is required to submit a mitigation negative declaration. A few environmental impacts that are listed as less than significant are emergency posts that will be installed every 75 feet due to the high suicidal rates on the existing bridge. Another mitigation is during construction of the tube, a net will be installed to capture any fallen debris, preventing disturbance to the bay. Also, under the cultural resources of the checklist, the project is located at Chicano Park near the murals, but have no impact due to no disturbance for designing of the entrance. However, one environmental impact that is potentially significantly impacts is the ADA compliance. However, the structural design will comply with the ADA slope. In conclusion, the proposed tube will have less than significant impacts to the environment.
The scope of the geotechnical investigation includes a review of available published maps, topography, previous studies, and other geotechnical relevant data, analysis and calculation of the soil mechanics of the surrounding area, along with foundational analysis in order to determine that the structure still remains a reasonable factor of safety or if additional design work and construction is required to ensure the integrity of the structure. Also included is consideration of surrounding fault lines and local earthquake activity. This is required to ensure that any additions or modifications to the structure or the surrounding area will not experience catastrophic or rupture failure. The base sediment is capped with soft, loose, sandy bay mud, according to the Coronado Bridge Geological Hazard Report performed by the Department of Transportation. By using data basin, we are able to determine that the soil is likely marina, loamy, coarse sand in the surrounding area of the bay and on Coronado Island. Many fault lines exist in the area, including the Rose Canyon fault zone. It has been estimated that this fault could register an earthquake magnitude up to 6.5 to 7.2. It is obviously a serious concern for the existing project. However, it has been determined that a catastrophic failure on the Coronado Bridge is not likely. In conclusion, our study covered transportation, structural analysis, method of construction, cost estimate, environmental, and the geotechnical aspects. We conclude that the bridge is not currently feasible due to the existing grades between piers 18 to 21, which exceed the ADA max grade of 5%. If the path was lowered to address this, the tube would further infringe on the Navy's minimum clearance of 200 feet. The project has a lot of potential, however, for the findings mentioned pertaining to ADA and Navy clearance, the project currently is not feasible.
We, Aztec structural consultants, thank Jim, John, and San Diego State. I believe that we will win.
Go Aztecs!